So in this problem, I'm asked to solve. So I want to figure out what values of x can I plug in, and the right side will equal the left side. I'm going to start by moving 7 over. So I subtract 7 from both the left and right. Okay, and then I'm looking, is it possible to factor something out? So I can see 2, 4, and 4. The highest number that divides into 2, 4, and 4 would be 2. I want to make sure I do this right. 2 times 1, attach x squared. 2 times negative 2, attach 2x. Okay, so can I do more? I'm checking to see is this factorable. Not everything is factorable. Sometimes you can factor. When you can't, quadratic square or quadratic formula or completing the square is what the options you have to rely on. 1 times negative 2 is negative 2. Are there two numbers that multiply to equal negative 2 and combine to give you a negative 2? So 1 and negative 2, or negative 1 and positive 2. Both these combinations multiply to equal negative 2, but neither combination combines to give us a negative 2. That doesn't mean we can't do this problem. It means we can't do this problem by factoring. So since this is not factorable, I'm going to go back up here and I'm going to start from the beginning. So I'm going to start right here. This is where I'm going to start from. Okay, so I'm going to start by moving 4 to the other side. It's not factorable. So I move 4 to the other side by adding 0 plus 4 is 4. And there's this blank spot. Now because the leading coefficient is different than a positive 1, I need to factor it out. And I always like to make sure that I did this correctly. 2 times 1, 2 times negative 2. Okay, good. What is next? So I look for the b value, and I'm going to take it, divide it by 2. Don't forget the sign in front. And then I'm going to square it. Negative 1 squared, that's negative 1 times negative 1, is a positive 1. But I did not just attach a positive 1 to the right side. In fact, I attached a positive 2 value. So on the left-hand side, you need to also keep it balanced by adding 2. 4 plus 2 is 6. Don't forget to bring down the factored out 2. What do I write next? You're going to take this and write it down, throwing an x in front. Okay, so how do we go about solving this? We're going to do PEMDAS backwards. Please excuse my dear Aunt Sally. So on the side that contains the x, outside of parentheses, is there any adding or subtracting? No. Is there any multiplying or dividing? Yes. 2 is being multiplied by this quantity. Opposite of multiplying is dividing. 3 equals x minus 1 quantity squared. So I've done the multiplying and dividing. Now the exponents. How do I get rid of a square? Square root. It also tells me there's 2 answers. And you're like, what do I do with the 2 answers? On the other side, we put a plus or minus in front. So x minus 1 equals plus or minus the square root of 3. And last thing, I've taken off the parentheses. I need to do the work. So I'm going to add 1 to the other side, putting it in front. So I have 1 plus or minus the square root of 3 equals x. These are the 2 answers. Those are normal, real solutions. There's no I involved. So how can you verify that this is correct? The easiest way to verify this is correct, and I will show this to students in class, is I'm going to come back up here to where it says 0, and if you could all write down y equals 2x squared minus 4x minus 4. So it's when it's equal to 0. I'm going to replace the 0 with the y. I'm going to graph this. And I'm going to see, are the two x-intercepts exactly 1 plus, so does it look like this? 1 plus the square root of 3, that's one x-intercept, or one solution, and 1 minus the square root of 3. That's what I'm going to check right now.